Well, the chapter 7 is doing things called estimates, and chapter 8 will be something called hypothesis testing. Both of them are a little different as what we had done before. Right, so the first chapter we separate or we distinguish the population parameter, the sample and the statistics, the relation between them. Right, and later chapter 2 and chapter 3 we see how to summarize the data and how we see the summary. Right? They basically are called the descriptive statistics. And there are two parts, right? The descriptive statistics, we got basically sample or population, pretty much samples. And what we do for that, using the graphs and other sample statistics like the mean, median, mode to find the central, variance, standard deviation, range to find the spread and so on other things, which is a summary of data, right, which we can see how the data works or looks like. And the other part is the inferential statistics. First part is estimation. What we can do with the estimation, right, what we use for them is use the sample statistic to estimate population parameter. Like for a poll, right, or for a vote, the most accurate answer is the population parameter, which go to the detail for everyone and asking their opinion and get the proportion. But before that, right, we can interview some people and ask random people, right, and ask them idea about the vote to estimate the population parameter. The sample we get, we can get the sample proportion, and based on other information of certain likelihood of such thing called confidence level. With certain things, we can estimate the population parameter maybe fall in what range. Like when we interview 1,000 people, saying 40% will be vote for and 60% will be vote against. And then from that, we can get the idea, like for the entire population, about what percentage will vote for and the remaining will vote against, right, for a thing. So which is use the sample to estimate the population parameter. It could be use the sample mean to estimate the population mean. It could be use the sample standard deviation to estimate the population standard deviation, or for the use the sample proportion to estimate the population proportion. Right, so that is the estimation. Of course, we'll see detail later soon. And another part is what we will see in the next chapter is the hypothesis testing. That's simply meaning to test the hypothesis, which hypothesis is a claim. What to do is test a claim. About the population parameter. Right, so the claim is only about the population parameter, and also still the evidence or the something we have on our hands we can deal with is still the sample. Right, and we figure out the sample statistic maybe could refer to the population parameter. Like just the brief example was the thing we see for the Coke volume last time. Right? We deal with 36 cans of Coke, and we see the average volume to be extremely larger than the set value of the volume is supposed to be. Then what we can conclude is if we do everything right, that it is more likely that the population mean, in that case volume, is a little increased. Was not the true as what it said before, or maybe years before as said, then this value now is increased. That is what we can conclude from that evidence. Actually, in the chapter 8, for the hypothesis testing, that is what we gonna do, and things will be a little bit more in detail from that chapter. And in this chapter, we'll go to the estimation, which use the sample statistics to estimate the population parameter. So that two things will be what we do for the remaining chapters. What we have done for 4, 5, 6 are tools, which we need to understand the probability to move on, right? Basically, the central limit theorem. Central limit theorem plays the very important role in these two chapters. Which the most important assumption, right, for the central limit theorem is what we get from the population as the sample, and this sample is simple random sample. Right, actually to do it, it will be very hard to keep, and that is the basic assumption we would make for our course, for this thing here. There are two types of point estimations. Right? The point estimate is a single value. Usually, right, the best point estimate of a population parameter will be the sample statistic. We'll see single value of a point estimate. And the other technique is called confidence interval, which is, I know the best point estimate will be the sample statistic, but of course it will be very less likely that the population parameter is actually this point estimate. Then we will have something called a confidence interval. We'll provide certain interval that it is certain confident that the true population parameter will be falls in that interval. Right, so that is certainly certain things called confidence interval. And of course, the confidence is a confidence level, so which means a certain level of confidence. Oh, we'll see that soon. And the estimate of population parameter will be, we use the sample statistics. For instance, the mean, right? We need to estimate the population mean is the mu. Then we could use the sample mean x bar as the sample statistic to estimate it as the best point estimate. The proportion is the lowercase of p, and the sample proportion is we can get from the sample. We could use p hat. The variance from population is sigma square, and to estimate the sigma square, we can use standard deviation from a certain sample. S squared. In those cases, we do not know any idea of the population parameter, then we can use this sample statistic to estimate that. And well, for our course here, we just go detail to the mean, especially. Right, proportion and variance will not touch them, right? So we only will focus on the estimate the population mean. And the best point estimate will be the sample mean with certain sizes, right? Certain number of data. And once again, the sample needs to be simple random sample, therefore the central limit theorem will be applied. Right, the confidence interval and the confidence level. A confidence interval is a range or an interval of values used to estimate the true value of the population parameter, and certain confidence level is usually in between. I mean, it's usually given the confidence level. So it's actually like when someone asks you, right, what is the for example, the let's say the Coke, right? What is the population mean volume of the Coke when you fill in right, for the can? You can say, I don't know, but I could draw a simple random sample of 36 cans of Coke, and what I found was the sample mean volume is 12.19 ounce. So I am like maybe 90% sure that the mean volume falls in between a certain that interval, which you can calculate out. Right, so that is the brief example, and what it does. Right? For example, for instance, for the mean here. To estimate a population mean, right? That was the example before. We actually do not know what it is, right? But we get the best point estimate is to draw a simple random sample and find out the sample mean. then we could calculate something called margin of error. Margin of error, which is the margin that differ from the mean, to the right and to the left. The margin of error is based on the distribution of the population, which the population follows the central limit theorem. Then the margin of error will be based on the z-score and the variance and the sample size. Recall that the z-score which this one is population over radical n, this one is the population mean. And for the distribution of the sample mean, which it could be given back to mean plus the z-score times sigma over radical n. Right, so the margin of error is actually this part. Right, the confidence level will refer back to the z-score, and if we know the population standard deviation, and if we know the sample size for sure, that will find the interval, right? The z-score is just referring back. It could be positive, could be negative. That will have the cutting value for the lower and upper. Lower limit and upper limit. Right, that is especially for estimate the population mean. Right, if we switch it up, that is the formula, right, for the population mean could be found by the sample mean and other information. Right? Maybe minus z-score, but actually it doesn't matter, right, for the positive or negative, since the value are symmetric for the middle. Right, so let's see how to actually get that. The sample mean is the best point estimate. Then the margin of error, it follows the normal distribution. Is the critical z-score times the sigma over radical n. So the next thing is what are the critical z-scores? What that's referring to. So how do we, from the certain of confidence level, to relate it to the critical z-score? So the confidence level is a level that of percentage, right? So it covers the middle percentage of the value. You can find those things in your z-score table, right? So the two area on the tail, each part is alpha over 2, the total is of 2 is alpha. And that cutting value is called the critical z-score. And the positive and negative, which will separate the bottom and upper for the scores. Right, the negative critical z-score and positive critical z-score are critical z-values that separate the area alpha over 2 on the left and on the right tails from the middle 1 minus alpha center area. Right, so for such value like question given that, well, using 95% as the confidence level, then we can separate that while finding the area on the left tail, refer back to the table to figure out what is the critical z-score in that case. Right, and for the z-score, usually what we can be used our usual confidence levels for this z-score using are 90%, 95%, and 99%. For the critical z-score, for 90% it's 1.645, 95% is 1.95, and 99% is 2.58. That value, right, maybe recall back to our empirical rule that before we say about 95% of the data fall in between two standard deviation of the mean, which that refers to z-score, right? Actually means z-score from -2 to 2, about 95%. In this case, we get accurate value. Actually, the z-score deferred the 95% center area is 1.96. Right, so which means for z-score from negative 1.96 to 1.96 is give the center 95% of the data. So which is roughly 2, but that is accurate. Right, so when we're given the percentage of confidence level, we'll use certain z-scores. So the way we do, right? So when sigma given, when the population, we know that the population standard deviation is given and it's satisfying the condition of central limit theorem, which the sample we get is simple random sample and the population is normal. If not normal, the sample size is more than 30 or both conditions satisfied. Then we can estimate the population mean. Of x bar minus e to x bar plus e. That is, the x bar is the point estimate and e is the margin of error. Where the margin of error is z-score times sigma over n, where the z-score follows those value of level of confidence. So level of confidence are provided in the question, and the critical z-score could be found in here, right? And the margin of error could be used by that formula. Right. So that basically is how we estimate the population mean if follow the condition of central limit theorem and we know the population standard deviation. Right, so such important thing as we have seen, right? The population standard deviation is known, follow the condition of central limit theorem, and we also need to know the confidence level and the sample size, right? And of course, sample mean is also needed. Right, so to estimate the population mean when sigma is given. I first check conditions valid, which means the conditions for the central limit theorem are valid. find this critical z-score corresponding to the confidence level, then what we need to do is evaluate the margin of error equals z critical times sigma over radical n, right? That is the thing we need to evaluate. And the method is confidence interval, right, under this confidence level. So we need to find the lower and upper limit for the confidence interval and write the S and interval. Then finally we need to draw a conclusion, right? So we do a bunch of things, and of course we need to make sure that other people are understanding what we are doing, right? So we need to draw a conclusion even for some other persons come pass, right? Come pass by, then they can actually read the conclusion. They can see what actually we are doing, right? So something like we have certain level confident, usually given the question like 95%, 90% of confidence, it is, again, important thing, it is a confident, right? So I'm just 90% of sure that the true population mean will be here. It's not a probability, right? Even though it looks like we use the way of probability to do the question, right? Like the distribution or so central limit theorem, but it is not a probability. Right? Why? Because the population appears is a population already, right? It's a set. A population parameter is a population parameter. It will not change based on what we are doing, right? So it's not like every time we do the question, the population parameter is changed, it stays. It's not a probability that the certain population parameter will be in somewhere. It is just our certainty. It is something like I am just that percent of confident. I just not 100% sure, but maybe 90% sure it will be in this interval. Right? This has some case that, well, it may be 10% that it is not in there. Right, it's just a confidence, but it's not a likelihood. Right, that thing is main concern. We can use the sentence, right, to say we have certain percent confident that the true mean of some object is between blah 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 and blah blah blah, two values, right? Here is confidence level, here is the object of the question asking, and between two values. Right, so that is a full step and a brief introduction of what the confidence interval of mean to do when the standard deviation is given. Right, so we'll see some examples of how to apply the information. It will be clear sooner, right, if certain steps maybe not that so clear to you, right? When we see the question, it will be more clear of what we are doing, right? So I'll see you next time.